Okay, so this is the last video for preparation for test 2. So talking about module 9 here. And module 9 is all about the binomial probability distribution. Okay, so one of the hardest parts I think about this binomial probability distribution is recognizing when you're in a situation where you have a binomial probability. So binomial, so when you see bi, right, that means there's two options. So let's go and read through this example. So a recent poll found that 18% of Americans enjoy running. Okay, so there's two options: either you enjoy running or you don't enjoy running. So that's part of what makes this a binomial probability distribution function. Another part is we continue to read and we see 5 Americans are randomly selected. Okay, so these are, since they're random, they're independent of each other, and there's a set number of Americans that we're sampling. There's 5. Okay, so n is 5. So we're starting to see the binomial distribution form, where p, the probability of success, the probability of yes, or the probability of the positive, in this case enjoying running, is 0.18 or 0.18. Okay, and n, the number of trials or the number of people that are selecting, is 5. Okay, so that's how we're recognizing, oh, this is a binomial probability distribution. I have my n and my p. Okay, good. So let's continue to read. Find the probability that exactly 1 out of the 5, so 1 out of the 5, so that means 1 out of this n equals 5 enjoy running. Okay, so that we see 1 out of a certain number, that's also a hint that this is a binomial probability distribution function. Okay, so what we want to try to find right now is the probability if I let x be the number out of 5 that enjoy running. Alright, what I want to know is the probability that x equals 1, exactly 1, so equals 1. Alright, so we do have a binomial probability distribution table, so let me pull that up. Whenever you recognize that we are in a binomial probability distribution problem, you should go to your table and see if it helps. So for us right now, our p is 0.18. We have 0.1 and 0.2, but we don't have 0.18, so actually this table is not going to help here. So next, we might, if you can't use the table, then you're going to have to use the formula. Okay, so let's see, where's the formula? There it is, right here. Okay, n over n minus x factorial, x factorial, p to the x, q to the n minus x. So we need to know how to use that. I can guarantee you on your test that you're going to have one problem where it uses formula and another problem that uses the table. So you need to know how to do both. Okay, so the formula, I'm just going to rewrite it here, is n factorial n minus x factorial p to the x q to the n minus x. Alright, let me just make sure. Right. Alright, good. So right now, this little x is 1. Okay, n is 5, so that's 5 factorial. N minus x, that's basically the number of failures, right? If total number of successes is, we have 1 success out of 5, so we have 4 failures. So 5 minus 1 is 4. Divided by 1 factorial. Then p is 0.18. Raise that to the first power. Q, what's Q? Q is 1 minus p. So it's basically the probability of a failure, or probability of not enjoying running in this case. So 0.82 raised to the 4, the n minus x. 5 minus 1. Okay? So 5 factorial, what is that? 5 times 4 times 3 times 2 times 1. 4 factorial, and then 1 factorial is just 1. Okay, so all these guys cancel. You're left with just 5. So 0.18 times 0.82 to the 4th. To the 4th power. Right. So let's go and type that into a calculator. 5 times 0.18 times 0.82 to the 4th power. And you should go ahead and round to 4 decimal places. So 0.4069. Right. So find the expected number of Americans that enjoy running out of 5. So if you have random samples of 5, how many would you expect that enjoy running? All right, so expected value is the same thing as mean. Okay, so you need to know the formula for the binomial distribution. Mu, which is the expected value, is equal to n times p. So in this case, that would be n is 5, p is 0.18. So just multiply those by each other. 5 times 0.18 equals 0.9. Okay, just leave it like that. The expected number of Americans that enjoy running out of 5 is 0.9. Don't round it to 1. It's tempting. A lot of students like to round these ones to whole numbers, but really what's going on here is if I were to get a random sample of five people and ask them whether or not they enjoy running, sometimes I'll get 0 out of the 5 enjoy running. If I were to go out and get another sample, I might get 1 of them enjoy running. 1 enjoy running, 0. And if I were to average all of those different samples of 5 up, I would get 0.9. So that's why expected value is the same thing as an average. Okay, so just leave it as a decimal. All right, don't round it to the next whole number. All right, then a standard deviation for the number of Americans that enjoy running out of 5. So let's start with the variance. All right, so variance equals n times p times q. So this would be 5 times 0.18. Q, remember, is 1 minus 0.18. It says 0.82. So that's basically going to be 0.9 times 0.82. So this comes to 0.738. Okay, so that's the variance. But the question says with standard deviation. So to find standard deviation, when you have a variance, just take the square root. So take the square root of the variance, and we get 0.8591 if you round to 4 decimal places. Okay? All right. So I believe I mentioned in the previous video, so this is really a Module 8 kind of topic, the unusual idea, but I'm going to go ahead and do it here for the for this binomial distribution, right? So you can use the range rule of thumb whenever you have any sort of probability distribution function. So we'll use it for this binomial probability distribution function. So if 4 out of 5 enjoy running, would that be considered unusual? Right, so we're going to use the range rule of thumb. So the max unusual value, using the range rule of thumb, is the mean plus 2 times the standard deviation. And you need to know this, okay? This needs to be something that you know. You're able to calculate this. So mu is 0.9, 2 times 0.8591. 0.8591. Okay, so go ahead and plug that into a calculator. 0.9 plus 2 times 0.8591. You get, oops, let me undo that. You get 2.6, I'm going to go and round to 2 decimal places. 2.62. All right? So would 4 out of 5 be unusual? So if the max unusual value is 2.62, then 4 is above that, right? So this is if I have a number line here, 0. The max is 2. So below there is usual. Right? I have to find the minimum usual value, but I don't need it to solve this problem, so I'm not going to. But below the max would be usual. Anything above the max would be unusual. So 4 is above the max, so it is unusual. Okay, so 4 is unusual. As a matter of fact, 3 would also be unusual. If we got 3 out of the 5 who enjoy running, that would also be an unusual outcome. Okay? All right, let's do one more example. All or actually let me go back to my list, and I like to check things off. So I've done this, I've calculated the mean, calculated the variance, I've calculated standard deviation. Only thing I have left is to use a table. So let's go ahead and use a table to find this guy. Practice doing that. Okay, so now we have a poll of college students that found 30% of them like campus food. Okay, so 10 college students are randomly selected. Find the probability that at least one likes campus food. So either you like campus food or you don't, right? So the probability of success here is 0.1. So there's two options, you like it or you don't, and the probability, oh, not 0.1, 0.3, sorry about that. The probability that you like campus food is 0.3. All right, the number that we're selecting is 10. Okay, so we want to find the probability at least 1 out of 10. So if x, let me go ahead and define x up here, to be the number out of 10 that like campus food. Okay, so the probability x equals, no, not equals, at least 1. So that means greater than or equal to 1, right? Greater than or equal to 1. So remember, either 0 people like campus food, 1 person likes campus food, 2, 3, 4, 5, 6, 7, 8, 9, or 10 out of 10 like campus food. So at least 1 means 1 or more, right? So we always use complements when you have at least 1. It's a lot easier. So 1 minus the probability that none of them like campus food. Okay? All right, so I could use the formula to figure out the probability x equals 0. But remember, whenever I know I'm using a binomial, I should always try to go to my table. So let's pull up the table first before I go to my formula. Is p equal 0.3 here? Yes, it is. It's right here. That's awesome. So let's see. Can I zoom in on this a little bit? A little bit. Yeah, p equals 0.3. It's right there. Okay. Now, what about n equals 10? Is n equal 10 here? Yeah, okay, sweet. It's right there. You see n equals 10 right there? This is n. It's 10. Okay, so now I have the table's going to work for me. So x equals 0, right? If I'm trying to find the probability, x is 0. And p is 0.3. Okay, so those two things, p 0.3. There it is, 0.028. Pull out your table and make sure you find that number as well. 0.028. Okay, 1 minus 0.028. On these problems, I'll go ahead and mention it on the exam, but if you round to 3 decimal places, obviously that's okay because the table only gives you 3 decimal places. Okay, so 0.972. So pretty good chance that you'll find at least one person that likes campus food out of 10. So now what about the probability that at most 4 like the campus food? Okay, so at most 4, if you were to think about that, 2, 3, 4, 5, 6, all the way to 10. Okay, so at most 4, so that means 4 or less, right? So including 4. So less than or equal to 4, right? 5 is not most 4. 5 doesn't work. 6 doesn't work. None of the other ones work. But 4 works. That's most 4. 0 works. That's at most 4. Right? That's less than 4. Okay. So let's see. To calculate this, I'm going to need to pull up my table again. So at most 4. So that means 4 or less. So I'm going to go here where it says 4. And I want to add up all these ones. All right. So I'm going to pull up my calculator and do this. So 0.2. And on the test, you would want to write all these guys down, so that way I know, exactly what you're adding, and so I know, if you make a mistake. So, but it's gonna be 0.2 plus 0.267, right? That's 3. 2 is 0.233. Okay. Then 1 is 0.121, and then 0 is 0.028. All right. So go ahead and double check that, but I think it comes out to 0.849. All right. So that's probability that at most 4 out of the 10 like the campus food. All right, yep, so that's everything. Like I said, if you have any questions about any of the stuff that I've talked about or anything related to the material that would be covered on the test, love to see those questions in the discussion board for the test, and we can, continue the discussion before the exam starts. So good luck as you're studying, and I hope it goes really well for everyone.